Welcome to this tutorial on simple linear regression. In simple linear regression, we use regression to study the relationships between two variables. The goal is to develop a model that shows how the two variables are related and to make predictions. A good way to understand this is to look at an example. Let's take a look at this example from Pearson's MyLab. A magazine publishes restaurant ratings for various locations around the world. Great. The magazine rates the restaurants for food, decor, service, and the cost per person. Develop a regression model to predict the cost per person based on a variable that represents the sum of the three ratings. Okay, so before I continue reading, let's define our variables. In simple linear regression, we have two variables. Let's call them x and y. X is our independent variable and y is our dependent variable. In simple regression, we're trying to predict the y variable using x. In other words, x is the independent variable that we are using to predict y, the dependent variable. So in this example, what are we trying to predict? We want to predict the cost per person, so that will be y. And what are we using to predict y? That is a variable based on three ratings. Let's call it a summated rating, and that is our x variable. Okay, let's click on the icon to see what we have. And now we can open this up in Excel. Great. Now let's see what the question is asking. Okay, part A asks to construct a scatter plot and then choose the correct graph below. So let's go ahead and do that in Excel. So let's click on Insert, and then if we click on Recommended Charts, you will see up comes the scatter plot. So let's choose that, and here we have the scatter plot. Now Excel uses the first column, column A, as the x variable, and the second column, column B, as the y variable. So we have rating on the x-axis, that's this horizontal axis, and cost on the y-axis, that's this axis. If you hover over the dots, you will see the x and y coordinates that are plotted. That can help you answer the question. We can see here that there are two observations that are a little more to the right on the x-axis, and this one is higher up on the y-axis. So now let's take a look at the choices in the problem. These choices in the middle we can immediately eliminate since they have the dots all lined up in a neat line, and that's not how our graph looks. It looks like either A or D. And then if I look for those two observations that are on the right of the graph, I can see that choice D looks more similar to the graph we got from Excel. And I think you would get A if you had switched around your x and y variables. So let's click here to get a larger view of the graph. And yes, it looks like the one I got from Excel. So I'm going to choose that. Click on D, check answer, and good job. Great. Now for part B. Assuming a linear relationship, use the least squares method to compute the regression coefficients B0 and B1. So in building the regression model, we need to have a y-intercept. That's where the regression line hits the y-axis, or the value of y when x is 0. That's B0. Here you can see the horizontal axis is labeled x, and the vertical axis is labeled y, and the point where the regression line hits the y-axis is called the y-intercept, or B0. Lowercase b is used for a sample, which is what we have here, but when we're talking about the population parameter, then we use the Greek letter for b, or beta, but we are referring to a sample here, so it is b, not beta, B0. And then we have B1, which is the slope, and that tells us how steep the regression line is. Those of you who took economics know it as the rise over the run, sort of like a staircase. How steep is it? In this example, we have an increasing relationship between x and y. As x increases, y is increasing, and so the slope for this example would be a positive number. What we're trying to do in regression is to predict y for a given x. So let's call the predicted value of y hat, and yes, that caret on top of the y is called a hat. So the equation is y hat equals b naught plus b1 times x. You might recognize this as y equals mx plus b from algebra, but in statistics we have the y-intercept first and then the slope. So it's y hat is equal to b naught, the y-intercept, plus b1, the slope, times x. I have a more in-depth video on simple linear regression you might want to review if you're not familiar with these concepts. Now let's get Excel to give us the regression line with a y-intercept and a slope. You can see here the graph doesn't have the regression line, so let's click on the graph, and then this plus sign pops up. This is the Chart Elements tool. So let's go ahead and click on the plus sign, and then click on Trend Line, and that draws the regression line on the graph. And now click on this arrow for more options. Click on More Options. Then make sure the linear button is clicked as you see here. Then scroll all the way down and let's check the box that says Display Equation on Chart. And this way we will get the regression line. And also let's check the display r-squared value on the chart. I don't think this problem asks for r-squared, but just in case, let's check it off. And so now you can see the regression line and r-squared are there. Let me make this a little bigger so you can see it better. Now Excel always gives the slope first and then the y-intercept, but in statistics we write the y-intercept first and then the slope, so don't let that confuse you. This number here, 1.367, is the slope, b1. You know that because it has an x attached to it. The slope always has the x attached to it. The number without the x is the y-intercept, b naught. That's this number here, negative 36.513. Okay, let's put that into the MyLab problem. And it says round to 2 decimal places. So for b naught, let's put in this number, negative 36.51. And then for b1, the slope, that's this number rounded to 2 decimal places. So that's 1.37. Check the answer, and we got it right. Now they're asking for the definition of the y-intercept and slope in the context of this problem. So the y-intercept is the value of y when x is 0. So for this problem, that would be negative $36.51 when the summated rating is 0, which really doesn't have any practical meaning because no operating restaurant is going to have a rating of 0, and the cost of a meal can't be negative. So this looks like a good choice. And then the slope b1 is the increase in y for every 1 unit increase in x, which is what it says here. The slope b1 implies that for each increase in 1 in the summated rating, the cost per person will increase by $1.37. That's b1, the slope. So let's check the answer. And yes, good job again. Next part is to predict the mean cost per person for a restaurant with a summated rating of 50. So that would be x. Let's plug in the values for the slope and y-intercept. Here is the y-hat line, also known as the line of regression. It is y-hat is equal to b naught plus b1 times x. From Excel, we know that b naught, the y-intercept, is negative 36.513. And b1, the slope, is 1.367. So that makes the equation y hat is negative 36.513 plus 1.367 times x. And according to the question, x is 50. So let's plug that into the equation. And we have y hat is equal to minus 36.513 plus 1.367 times 50, right? X is 50, and that is equal to 31.837. Great. Now let's use Excel and let's define x as equal to 50. The y-intercept b0 is negative 36.513, and the slope b1 is 1.367. And here I'm using Excel just like I used the calculator. So using the equation y hat is equal to b0 plus b1 times x, let's let Excel do the calculations. And of course you can use a calculator if you want to. And I'm just doing it both ways. So I have the equation here in Excel and we get the same number, 31.837. So let's type in 31.84 since MyLab wants the answer to the nearest cent, and nice work. Great. Now that was an easy problem, so let's do another example, but this time let's use the data analysis tool to help solve the problem. Let's take a look at this problem. An agent for a residential real estate company in a suburb located outside a major site has the business objective of developing more accurate estimates of the monthly rental costs for apartments. So monthly rent would be our y variable, our dependent variable. That's what we're trying to predict. And next it says that towards the goal, the agent would like to use the size of an apartment as defined by square footage to predict the monthly rental costs. So now we have X. That would be the size of the apartment in square feet. The agent selects a sample of 8 one-bedroom apartments, and the data are shown here. So let's take a look at this. We have monthly rent, that's Y, and size, that's our X variable. It's important not to mix up these two, since if you do, you'll get the wrong answer. X has to be plotted on the horizontal axis and Y is on the vertical axis. Y is what we're trying to predict, the cost, and X is the independent variable that we're using to predict Y, in this case, the size of the apartment in square feet. Okay, let's open this up in Excel and let's check to see that the columns are first X and then Y. And no, this first column is Y, the monthly rent, and then X is size. We want to make sure that it's not going to give us the wrong X and Y axis. So if we're using the charting tool to create a scatter plot the way it is now, then the default for the charting tool is the X and Y switches would be switched the way it's set up, because Excel would then use size as the Y variable that I'm trying to predict, and that's wrong, of course. We're trying to predict monthly rent. And so the charting tool would take the first column as X and the second column as Y. And so let's switch these columns around so that X is the size of the apartment and that appears first, and then Y the cost. So I just did a simple copy and paste to switch the columns around. There is an option in the charting tools to switch the X and Y axis if you didn't do it this way, so you could do it that way as well. Okay, now that I have those two columns swapped, let's make sure we are on the Insert tab, and if not, then click on Insert, and then Recommended Charts, and it gives us the scatter plot as a recommendation. Great. Notice the label at the top of the chart says monthly rent, and that's our Y variable, so that is correct. Make sure the Y variable is the label here at the top. If it had said size here at the top, then we would have our X and Y variables switched around, and that's not good. Okay, click OK, and we have our scatter plot. Now let's go back to the question. Part A is asking to choose the correct graph below. So again, I can rule out C and D right away because these show the dots all lined up in a nice neat row, and my chart is not so neatly lined up, so the answer is either A or B. And so now let's take a closer look at the scatter plot and see which one it looks like, A or B. And if I hover over one of these dots with the mouse, you can see the X and Y coordinates. This dot is 2000, 1950, so X is 2000, Y is 1950 for this coordinate, and that can help us to answer the question. But also visually, I can see this dot is out to the right, but at the top. And now going back to the problem, A has a dot plotted at the top right, and B has a dot plotted at the bottom right, so it has to be A, right? And good job. Next, the question asks for the y-intercept, B0, so let's click on the Chart Elements tool. That's this plus sign here. And then at the bottom, click on trend line. That's what Excel calls the regression line, a trend line. And you can see as soon as I check the box, Excel draws the line. But I need the equation since just having the line doesn't give me the y-intercept and the slope. So click the out arrow and then more options. And then under trend line options, scroll all the way down to where it says display equation on chart. And check that. In another problem, we might have to also calculate R squared, the coefficient of determination. So if you need that, then check that box as well. Okay, so now I have the y-hat line, the line of regression, also known as the least squares line. Except that Excel gives us the slope first and then the y-intercept, but in statistics, we write the equation with the y-intercept first and then the slope. So this first number, 0.9383x, is the slope, B1, that's always connected to the x term, and then this second number, 251.01, is the y-intercept, that's B0. So remember, if you use this trendline function in Excel, then you should know that the slope and y-intercepts are written backwards to the way we write it in statistics. Okay, so this number is B0, the y-intercept, so let's go ahead and put that in the problem. 251.0, check answer, and excellent. Now for B1, the slope, that's 0.9 to 1 decimal place, and nice work. Now, interpret the meaning of the y-intercept and the slope. Well, the y-intercept is the value of y when x is 0, or where the line of regression hits the y-axis, and the slope is the increase in y for every 1 unit increase in x. So as size increases by 1 square foot, then monthly rent should increase by whatever the slope is in dollars. And as I'm reading this, A looks like the best answer. For each increase in 1 square foot of space, the monthly rent is expected to increase by B1. Since x cannot be 0, B0 has no practical interpretation. That makes sense. And we are right. Nice work. Okay, next part. Predict the mean monthly rent for an apartment that has 1,000 square feet. Okay, so let's plug that into the regression line. X is 1,000. The y-intercept is 251.04. The slope is 0.9383. You can use a calculator. I'm just using Excel as a calculator. So y-hat is equal to the y-intercept. That's in N6 plus in parentheses. You don't really need the parentheses here since Excel follows the rules of mathematics and will anyway multiply before adding. But it's a habit I have, so now the slope times x, N7 times N5, and I get 1189.34. So let's see, round that to the nearest cent, and that's right. Part E. Why would it not be appropriate to use the model to predict the monthly rent for apartments that have 500 square feet? Well, in regression, we are building a model based on the data, and the data that we have has apartments ranging from 750 square feet to 2,000 square feet. So 500 square feet is a much smaller apartment than the apartments in our data set. So it's what we call outside the relevant range that we can use the regression model for, since we don't know if the relationship between x and y holds true below the smallest observation of 750. So B would be the correct answer. An apartment with 500 square feet is outside the relevant range for the independent variable. One more question. 2 people are considering signing a lease for an apartment in this neighborhood. They're trying to decide between 2 apartments, one with 1,000 square feet for a monthly rent of $1,275, and the other with 1,200 square feet for a monthly rent of $1,425. Based on A through D, which apartment is a better deal? Well, we already calculated that an apartment of 1,000 square feet should cost around $1,189, so the $1,275 is above that predicted value based on the data. It sounds like it's overpriced. Now let's see what the predicted value of a 1,200 square foot apartment is. So let's plug in 1,200 as x in the regression line. X is 1,200. So let's calculate y hat is equal to the y-intercept, n6, plus the slope, n7, times the new x value of 1200 that I have in n10, and we get a y hat of 1377. So that's actually less than what they're asking. They're asking for 1425. So the 1377 is actually a good deal or underpriced for the 1200 square foot apartment, whereas the 1275 is not a good deal for the 1000 square foot apartment since the predicted rent would have been lower. So the apartment with 1200 square feet is a better deal. Great! Now let's take a look at how we could also get these answers using the data analysis tool. Under the Data tab, click on the Data Analysis tool, then scroll down to Regression, click OK, and now put in the Y range, that's the B column, and then the X range, that's the A column. Check the labels since we do have labels in the first row. Click OK, and here we have the summary output with lots of great numbers. You can see the coefficients down here. This is the y-intercept, B0, the same number we got from the trend line. And here is B1, the slope for size, also the same number we got before. So this is another way of getting exactly the same information. Also up here you can see R squared, that's the coefficient of determination. We didn't need that for this problem, but it's good to know anyway. And so now that is it for the basics of simple linear regression using the charting tool and using the data analysis tool. I hope you enjoyed this video and I hope you learned something.